In section 8.1 part 2, now we're going to be working it backwards, asking the question, how large of a sample size do I need to get this particular confidence interval? And the way we're going to do that is whenever they're talking about how large of a sample size is needed, that's always rounded up to the next whole number. It doesn't matter if it comes to like 10.6, you round to 11, or if it came to 10.1, you would still round to 11. So just please keep that in mind. So this particular problem gives sigma equal to 17.8, and the question says how large of a sample size must be drawn so that a 99% confidence interval on the mean will have a margin of error of 1.3. And they say round up to the nearest integer. That's what I was just talking about. You always round up. On the formula sheet, it equals to n is equal to the critical value times sigma divided by the margin of error, and that is all squared. So I still need to find the critical value. I either find it from table A3 if the confidence level given is on table A3 at the bottom, or I have to do that calculation which I went over at the beginning of the first section 8.1. 99% confidence level is given on table A3. It's at the bottom, and again, just to show you where it is. 99% is right here, 2.376, or 2.576. Sorry, it's hard to see the numbers, but you can be looking at your table while you're doing this. So that's what I have here, 2.576, right there. And it says now plug in the numbers. So the sample size is going to be the critical value, which is what I just looked up, 2.576, times sigma. Sigma was given as 17.8 at the top of the problem, divided by the margin of error, and this margin of error was given at 1.3, and square it. So the first calculation I did was 2.576 times 17.8, and that came to 45.85 divided by 1.3 still. So when I do 45.85 divided by 1.3, I get 35.27. So I take 35.27, square it, and that comes to 1244.07. So even though this 0.07 in regular math would not be a round up to 1245, because I'm looking for a particular sample size, I do have to round it up. So I round it up to 1245. So in general, if the sample size increases, the standard error decreases, the margin of error decreases. If the sample size decreases, the standard error increases, and the margin of error increases. If the confidence level decreases, the critical value decreases, the sample size decreases. If the confidence level increases, the critical value increases, and the sample size increases. On this next example, a simple random sample of 100. This is some lifetime electronics thing. The mean lifetime is 125 hours. Sigma is 20 hours. Construct a 90% confidence interval for this particular, I think these are batteries, for this particular battery. So from the table A3, 90%, again at the bottom of table A3, comes to 1.645 for the critical value. Standard error is sigma over square root of n, so it's 20 divided by the square root of 100. The sample size was 100. Square root of 100 is 10, so 20 divided by 10 is 2. The margin of error is the critical value times the standard error, so it's 1.645 times 2, which comes to 3.29. The interval will be the mean minus 3.29 and the mean plus 3.29. So the mean is 125 hours, minus 3.29 is 121.71, and then the mean plus 3.29 is 128.29. On this particular problem, they want you to round to a whole number. So I'm going to round the 121.71 to 122 and the 128.29 to 128. Again, I'm using regular math for this rounding. So if I wanted to talk about this, I could say that I'm 95% confidence that within these samples, or within the samples of each of 100, that the battery life would be between 122 hours and 128 hours. Then the question goes on to say, find the sample size needed so that a 99% confidence level will have a margin of error of 2. So sigma is 20. From table A3 at 99%, again, that number is in there. The critical value is 2.576. So the formula to find how the sample size is critical value times sigma over m squared. So it's 2.576 times 20 divided by 2. 2.576 times 20 is 5152. 5152 divided by 2 is 2576. When I take 2576 and square it, I get 663.57, and this, whenever I'm looking for the n, this is always a round up, so I round up to 664.